Hello. Today we're going to talk about infinite geometric series. So an infinite geometric series is an example of like a bouncing ball dropping, and it bounces and bounces and bounces and bounces and bounces, but it bounces less every single time. So at what point are you barely adding anything? And so you can go on infinite. So an infinite geometric series, if we look at it, if I say, okay, 1/2 plus 1/4, so if I start with these and I add these together, that's 3/4. So if I add a partial sum is when I add only so many terms. If I only add 2 terms, I'm at 3/4. If I go and add another eighth to it, now I'm at 7/8. And do you notice I'm adding less and less and less to that? And so when I graph this, the distance traveled, or the sum, every partial sum is going to become less and less and less and less. And can you see that eventually it's going to never quite reach a certain value? But if you take it to the infinite, we say it does. So start with your formula from yesterday or before. And remember that this term right here is kind of like that term after the last term. So now if that term keeps approaching 0 as n increases, then this, as I separate this, will become 0. So I'm going to be subtracting nothing. So what's really cool is that the formula for finding infinite series is actually simpler than the formula it is for finding partial sums. And so here's the important piece that you need to know. The formula, and we're not going to use s of n, we're just going to use s. And that's going to assume an s to infinity. And it's just your first term divided by 1 over your r. Now here's the next part. This r has to be in between -1 and +1. In other words, it's got to be a fraction. It's got to be something smaller than 1 so that it's approaching. It's not getting bigger. And yet it even works, even negatives, even if it's alternating, it'll be a convergent series. And so it'll converge to the point where each term adds less and less to it. So, but if you had an r that was greater than 1, whether it be 1.5, 2, 3, 4, then it's just going to continue growing larger and larger and larger. And the sum of an infinite series with an r bigger than 1 will be infinity, because it'll continue to grow. So let's continue on. If I look at these two combinations, what do you notice? And the big thing is finding the r's. Do you notice how 2 plus 4 plus 8 plus 16, I keep adding more and more and more. So there is no infinite sum on this first one. But if I start with 16, and then I add an 8, and I add a 4, and I add a 2, and I keep taking half of that, well, eventually the amount that I keep adding to get to the next term is going to get so close to 0 that by the time it gets to infinity, it will be 0. So you have to pay attention to what you're actually adding together. So let's do a few examples just so you have an idea of this. Here's your formula, and it's simpler. S equals a of 1 over 1 minus r. So if they give you the first term, s will equal 36 divided by 1 minus your r of 2/3. Yes, there's going to be fractions on the bottom. That's okay. I'll show you how to handle them in just a second. So let's leave that 36 up there. Over 1 take away 2/3 is only going to be 1/3 left over. But remember, how do you divide by a fraction? This is really important. We forget about this one a lot. This is the exact same thing as saying 36 times the reciprocal, which is 3 over 1. And do you notice over 1, it's really just a whole number. And so you can just grab your calculator, and you can go 36 times 3, and you get 108. And that is your infinite sum of that series. Okay? So then you'll move on. Number 5, you look at this and you'll say, okay, let's do it again. But you can stop right here and just circle this r is negative 1.5. Remember, it had to be, your r had to be in between. Yes, it's less than 1, but it had to be greater than a negative 1. Being this is outside the bounds, this is not going to be a convergent series. And so this will not exist. Okay? So it does not exist. Now, if they phrase it to you a little bit differently, like number 6 here, you've got to find out what is my r. Now, obviously, a of 1 is your first term, so that's easy to spot. But to find r, good refresher, it's your a of 2 divided by your a of 1 in a geometric series. So you can take this 24 and divide it by a 16. It may not work into a nice, don't go decimal. Generally, decimals are a little more messy. Keep it with the fractions, but reduce it. What can I divide out of both of these? So I see I can divide at least, well, can I divide 8 out of each of these? Divide by 8, divide by 8. And that's going to leave me a 3 over 2. Hang on a second. 3 over 2. Isn't that the same as 1 and 1/2? And isn't that bigger? Look at that. There's a sneaky way. This also does not exist. Exist. Okay. So let's do it again. What if they give us fractions? I know you're thinking, oh, fractions, don't worry. You got this. So your a of 1, right there. R equals your second one, which is 1/6, divided by your first term, which is 1/4. Don't freak out, because remember, dividing a fraction is the same as multiplying by the reciprocal. So 4 over 1. So flip it. Flip it. There you go. You get 4/6, or you can cross cancel just a little bit, end up with 2/3. Now that r is less than 1, so we can put this back into the equation. And so our infinite sum will be our first term, which was 1/4, divided by 1 minus our r, 2/3. Plug it in, take care of the bottom first, 1, take away 2/3. Hey, that's another 1/3. And even though you have a 1/4 sitting up right here on top, don't worry. 1/4 times by the reciprocal, 3 over 1, is the same thing. So that's it. That's your step. Multiply those together. They can't even cross cancel. Your answer is 3/4, and you're ready to go. So infinite sums, they go on forever, but they kind of don't. They plateau. There's a limit idea to these. So good luck. Have a great day. Hope this helped.